Yeah, so the topic of today, we are going to basically introduce you to competitive programming. So, first of all, let's see the agenda of this meeting, right? So, why are we here, and why should you listen to us, basically? So, what we are going to do is we are going to introduce you to what's whys, and hows of competitive programming. So, what is competitive programming? Why should you do it, and how should you do it? That, and then we are going to basically teach you the essentials of doing competitive programming. So, like before starting any skill, like before doing anything, we must be equipped with some essentials so that we can tackle it, tackle the thing. Well, if we directly jump into whatever it is that we're doing before actually knowing the essentials, it won't do us any good, right? So, yeah, we are going to learn some essentials about programming, the ABCs of competitive programming, time and space analysis, so that you can start off solving problems on your own, right? And we are going to take a look at some important topics in competitive programming that are going to help you in your future, which are like greedy algorithms, bit manipulation, frequency arrays, etc., pre-computation and stuff. So these are like the building blocks of competitive programming, and this is what is going to help you solve some good amount of problems in the future, right? So this is going to be the agenda of the meet, and the first and second part will be like very quick. We will be done with them very quick, and we will be mostly stressing on the important topics that you have to learn, uh, uh, i- i- which are going to help you doing CB, right? So, well, first things first. What is CP? So CP is, competitive programming is popularly referred to as CP. It's basic. Wherever you go, you find people calling it CP, 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 and stuff. So CP is basically competitive programming, and it is a team sport in which a person or a team, they will be given some algorithmic problems, and then you are supposed to code it, right? You're supposed to code the solutions to it. Now let us take any exam that you're writing, right? So let's take JE or something. Where in JE, what is done, like you're given some set of questions, and and then you're supposed to solve it within a time frame, and then the highest marks guy, the highest mark people, they get rewarded, right? So here, I'm not comparing this to JE. Don't I'm not I don't want to bring back that trauma to you guys anyway. Yeah. So, yeah, what happens here is you're basically given a set of algorithmic problems, and the interesting thing here is it might be a person based or a team based. You can do it as a single person, or you can do it as a team entity. It depends on what you're doing. It depends on the contest that you're giving anyway. So what is a contest? I'll explain you slowly, right? So yeah, that is the crux of competitive programming. You're given some algorithmic problem set, and then you are supposed to code it in any language of your choice, any programming language of your choice. It's not like I will do it only in C. I can do it only in C++ plus plus or something like that. There is no language barrier as such. You can code these algorithmic problems in any language that you want to, that you are good at, and you are basically ranked on the efficiency of your solution. How efficient is your solution, and the time in which you come up with a working solution. Like if someone solves the question in 2 minutes, and you solve the question in 1 minute, you are of course ahead of them, right? So you are placed better, you are ranked better on the leaderboard. So that is basically competitive programming. It's basically two words: competitive and programming. You do programming and then competitively. Yeah. Okay. So let's talk about why you should do CP. No, of course, funny slide. Uh, it's fun, man. I don't know how to put it to you exactly, but then once you start doing CP, it kind of gets addictive, and then at least for me, and a lot of people around me, a lot of people in this college especially, I've seen that it is basically a mind sport which gets addictive at some point. It's like you want to solve questions, you want to solve more and more questions. The more you do, the more dopamine hit it gives you by seeing that accepted solution. So, why CP? Why, if you would ask me as a person, I would say it's just fun to do. That is what I would tell, right? So, and apart from that, and I know probably most of you are here, and most of you would have heard that by doing competitive programming, you are more likely to be hired by using Facebook, Amazon, Google, or whatever. So, what actually CP does to you is it basically twists your brain, right? It forces you to think. Competitive programming forces you to think, and of course, these companies, they mostly focus on problem solving skills. So they hire people with some good competitive programming background. So this is basically a byproduct of something which you do for fun. Right. You do competitive programming for fun, and then now that your competitive programming skills are nice and stuff, you get recognized by FANG and you possibly get hired by FANG. I'm not telling you that necessarily everyone who's good at CP will end up in FANG, but then it is more likely to happen in that way. All other considerations aside, it is more likely to happen that way. So yeah, no. Next. So how do you do CP and where do you how do you do CP and where do you do CP? Right. So there are some really good websites that you can check out for doing competitive programming, and like the best website out there is codeforces.com. Right. I'll just um, uh, yeah. So this is basically the interface of Codeforces. And what happens in Codeforces is you usually have basically CP is all about these contests. Okay. So, contest is basically, if I were to put it to you in a very plain language, is basically an exam and exam sort of thing, right? So now this is basically a contest. Okay. Now I've opened this problem. This entire question set is called the problem set, and what happens is you are given this problem set within a time frame, right? This contest usually starts at 8 o'clock. Like every contest in code courses usually starts at 8 o'clock, and once the clock hits 8, you are given these set of problems, and then you are basically required to solve these problems. So you have some problem statement here, which basically asks you what to do, and then there is input format, and then there's output format, and then there's example input, example output. So yeah, I'll be discussing this in detail very soon. Right. So what happens in these contests is you are given this particular problem set, and then you are required to solve how many questions as ever you want in that particular time frame. Right. So, and yeah, you can see this leaderboard, right? So the top person solved like up to E2, yeah, like up to E2 questions in like 2 hours 6 minutes. So the better your the better score you have, like the more number of problems you solve, and the faster you solve it, like you get to be on top of the leaderboard, right? So this is basically the crux of competitive programming. Whatever happens in competitive programming, particularly this. And of course, you can see your friends standings over here. If you have friends who are interested in CP, you can see how they've performed in the contest as well. And there is this thing called the rating system, right? So if I take this user in particular, so this user is basically a legendary grandmaster. So he has like participated in like a lot of contests. This thing is called a rating graph, right? So the more contests you participate in, and the better you perform, the rank, like the better you perform. See, this guy got rank 11, rank 18. So his graph is like this, an increasing graph. So the more you perform in these contests, the well you perform in these contests, the better you get at competitive programming, and yeah. So this rating thing increases, right? One very nice thing that I would like to mention over here is I'm sure a lot of you might have played Valorant, Counter Strike, or any of such games, right? So there is this particular thing called a rating system or a ranking system or elo, whatever you call it, right? So we basically flaunt our rank over there. Oh yeah, I'm diamond, I'm platinum, I'm immortal, something like that. So it just feels nice to have something brainy, techie in that area. So you can basically flaunt this rating if you are good at it. And then yeah, and also one thing that I'd like to mention is don't take these ratings things very seriously, right? So um, yeah, it's not like if you have a better rating, you are good at CP and something like that. It's rarely like that, but then this is a very good motivation to do competitive programming. So that's that, right? So this is about code forces, and what happens in code forces is usually you have a contests on random days starting at 8 p.m., usually lasting for 2 hours and 2 hours or 2.5 hours, right? And then this code shift. I know a lot of I hope a lot of you know about code shift, right? There is like a contest that happens on every Wednesday called code shift starters, and in fact there was a contest yesterday. Yesterday's Wednesday, right? Yeah. So there was a contest yesterday. I hope a lot of people have given you that contest, and I think your faculty also might as well suggested you to do coach of in your in your classes, right? So that's that. Yeah, so when you go to CodeChef, you get to see this page called Compete. In this Compete page, you can see all this contest, all the previous contests. Like it happened on March 13th, 2024. So you have the problem set, and you go to whatever division you want, like based on your rating. And then you see a set of problems, and then you try to solve it. Nothing fancy, same competitive programming stuff, right? So if you want to practice some questions, there is also a practice page. So you can come over here and practice problems. And I would suggest you to guys to go to old practice page and solve the problems over there. Because this is like better. You can sort the questions based on the difficulty, and you can practice problems as much as you want and in whatever difficulty that you want. So CodeChef is a really nice platform to hone your competitive programming skills. Right. After CodeChef, my personal favorite is AtCoder. Right. AtCoder is like a Japanese competitive programming website, which basically has these beginner contests and regular contests. Right. So these beginner contests are usually very good for beginners. Same thing. These contests usually start at 5:30 p.m. On Saturday, and of course you have some tasks you have to solve them, and then there are standings, nothing fancy. But the questions of AtCoder are really good, and with each and every question you get to learn something new. So that is what I like about AtCoder, right? So these are basically where you can do competitive programming, right? Okay. Yeah. So let's look at another interesting thing called CSES problem set, right? So there is this thing called CSES problem set, and this is not really a competitive programming website, but then it's basically a question bank. You can call it a question bank, right? So there are some problems. There are some really nice problems in CSS problem set. There are some introductory problems which are basically just implementation based. Like you do not need to have any algorithmic knowledge to solve this, but then a good language knowledge is enough to solve these kind of questions, right? Language specific things are okay, right? And then there is sorting and searching based on these greedy algorithms and stuff. And then there is dynamic programming, graph algorithms, range queries, and tree algorithms. These are so this is kind of an advanced version, right? So for now, I'd like you guys to stick to these introductory problems and sorting and searching problems. They're really nice. So if you want to practice something very vigorous, I would suggest you to come down to CSES problem set and check it out. It's really nice. Right. Okay. Now that we are done with hows and wheres of competitive programming, now let's get back and like let's learn about what is essential to do this competitive programming. Now, right. So, fine. How many of you know about time complexity here? Can I get a thumbs? Yeah, I am assuming a lot of you. Thank you, thank you. Right. Yeah, it is basically in your curriculum, maybe, I guess, for, at least for CSE and allied branches. It, DSA, karke, there must be a course. Yeah, yeah. Yeah. So, yeah. So, what basically this time and space analysis is like extremely important when it comes to solving any competitive programming question. Now, say, let us open a question, right? I'm opening this question, and then you can see all this information in the question, and then there is this thing called constraints, right? So, and also to people who actually do not know how a question looks, I'll just take 2 minutes of 2 minutes of time to explain you how a question is supposed to look in competitive programming. Like anywhere, the format in which they give a question in competitive programming is very similar. First of all, you have this problem statement which says what is supposed to be done, right? So in this question, it says Alice is going for a drive. She reached a maximum speed of s kilometer per hour, and then as per rules, speed of vehicle must not exceed 40 kilometers per hour. Otherwise, the person will be fined. You need to tell whether Alice will be fined or not. Very basic, very plain, very simple question. Right. So the input format is something like this. One line of input will contain a single integer s denoting maximum speed Alice reached while driving. Right. So this s will be given to us, and our task is to find out if she oversped or not. Simple thing, simple if condition. If s is greater than like greater than or equal to 40, she has oversped, or not, she has not. It's as simple as that. So there is an input format stating how these numbers are given. Like for now, it's like a very simple input called 40, and then you read it somewhere in your code, and then you process it, right? And you process it, and then you print yes if Alice will be fine, or otherwise you print no. It's a matter of scanf. It's just a matter of scanf and printf, right? So why these constraints is so important now? Now maybe this constraint part in this question it's not really relevant, but then yeah, I'll explain it anyway, right? So constraints, it just means that whatever s is being given to you by the online judge, it's basically the s will always lie between 0 and 50. It's never that you will be given some number over here which is greater than 50, right? So that's that. You don't need to explicitly check this condition. Like you don't need to write a code if this condition is met or not explicitly, because it is always met. If given constraints, if constraint is given, it is known that the condition is always met whenever they are giving you an input like this, right? So yeah, there is a sample input and output for 40. It is a no, because like 40 kilometers per hour is the limit, and she has not reached the limit yet. 40 is okay, but 41 is not okay because she has oversped and it is over 40. Because that is why you print yes, because she oversped. Okay, and there's explanation, of course, of why this thing is happening as such, right? So this is how the skeleton of a question in competitive programming looks, right? So now let's look at time and space analysis. Why we need to analyze time such, and also in more info, if you see, you will be given some time limit for every question, right? So it's not like you write any code and it works. No, no matter how much correct answer it is giving, you can't really write a code which takes a lot of time to execute, and that execution time is estimated by time complexity, right? So I'll talk a little about time complexity now. So now let's not go into the technical thing of time complexity, but then roughly I'll just tell you that it's approximately the number of operations it takes to fully run your code. Right. So Um, can anyone tell me what the time complexity for bubble sort is in the chat? You are able to use the chat, right? Yeah, yeah. Yes, that is correct. Yeah, that O of n squared. Only one. What about everyone else? Um, you guys are listening, right? Yes, cool. Yes, correct. Thank you very much. So, hmm. So the reason why the complexity of bubble sort is O of n squared is there are basically two loops. Uh, right. First loop, the I loop running till n, and the j loop running till n again. So that just so happens that the entire thing will run twice, n times the outer loop, n times the inner loop. For each iteration in the outer loop, the inner loop runs n times. It takes n squared operations all over. Right. So that is why the complexity of bubble sort is order of n squared. Right. And yeah. So that's that. Number of estimate, a rough estimate of number of operations is the time complexity. Right. And of course, the lesser the time complexity of your code, the better it gets. Right. If your code is like if someone writes a code which is executing in like 5 seconds, and someone is writing a code which is you are writing a code which executes in 1 second. Of course, if you look at it in a bigger scale, it's like your code is like 5 times faster than their code, what they have written, right? So it becomes a very important parameter in judging how good your code is. Time complexity becomes a very important parameter in judging how your code is, right? And also in competitive programming, while solving any kind of problem, like almost any kind of problem, 99% of problems, you are supposed to look at your code, estimate its time complexity, only then submit the answer. Right. You cannot write whatever code that you want, provided like I mean, some codes just work. Okay, your sample inputs might pass, your logic might be correct and stuff, but then your code might be too slow to get executed. So that is why you need to estimate the time complexity of an algorithm. Right. And of course, there are three types of notations, like the big O notation, which is like the worst case time complexity, the theta notation, and the omega notation. And also the thing is, we will be only dealing with a big O notation in the entire competitive programming. You never get to find people who talk about average case complexity or best case time complexity. We only talk about the worst case time complexity in competitive programming, right? So yeah, I'll just give you a very brief overview of what exactly worst case time complexity is, right? So let's just say I have an array 1, 2, 3, 4, and 5, and I am searching for an element called 2. Right. So, and say I'm linear searching on this array. What I will do, I will see if 2 is equal to 1. 2 is not equal to 1. So I'll move forward and then say I'll see if 2 is equal to 2. Yeah, this is correct. Right. Now, the thing is, now that I have searched for 2, I came to my answer really quick. That my 2 basically lies over here. But then say I am searching for 5. Now what I will have to do is I will have to search for the entire array, come up till the end, and say 5 is at the end and stuff, right? So the complexity of finding 2 is basically O of 2, right? Because like I take 2 operations to find 2, and the complexity to find 5 is basically order of 5, and the worst in between among these two is basically order of 5, and that is what I consider as my worst case complexity. Right. Uh, right. Yeah. So that is the crux of worst case time complexity. Right. So whenever you see a problem, like okay, let's talk about linear search anyway. Now we say that the complexity of linear search is order of what? By the way, what is the complexity of linear search in the chat, please? Yeah. Yeah, Vatsalya, correct. Best case O of 1. Worst case complexity is order of n. Yeah. The worst case complexity of linear search is order of n, because you might find your element at the very end. Now, why this is called worst case complexity, or how worst case complexity is basically derived is, you basically consider the set of the worst input possible for a given array. What might be the worst input possible for linear search? Now I give the search element x as an input. What might be the worst element which causes the worst performance in linear search? If this is x and nothing else here is x, then I can say that this linear search will cause some worst performance, and it will basically take order of the length, which I call it n. Right. So, well, that's that. That is how we estimate worst case time complexity. Right. Now, let's take a look at some examples. Hmm. So, can someone tell me what the time complexity of this code is? And also that I would like to mention to you guys right now, he do not code in C++. Sorry, C. Stop using C for whatever the reason that you're doing. I mean, for academics, it's fine. You will have to do that in C. But I would really recommend you guys to try out C++. It's not really more different than C. I'd rather say that it's easier than C. I personally, I've learned C++ first, and then I switched to C. Right. So yeah, so this is basically a C++ code snippet, and cin is basically equivalent to scanf, and I am reading an input, and cout is basically equal to print. I am printing the output. So what is the worst case time complexity of this code? It would be nice if I get more reactions. Mhm. All right. Yeah. So the worst case complexity of this code is order of n, because like this for loop runs for n times. Yes, correct. Thank you. So the number of operations this code takes in worst case is is basically n. The number of operations, like the number of times this for loop is going to run, is basically n. Right. Okay. Now, what is the complexity of this code? Of n by 2. Okay. Any other answers? Of n. Which is it? O of n or O of n by 2? Okay. O of n, O of n. Okay. Right. So, so obviously this there is this small thing called I plus is equal to 2 over here. Right. So starting from 0, we will take 2 jumps every time and skip half the elements. Right. So intuitively, the number of operations it might take is basically whatever is given and are divided by 2, n by 2. Right. So it basically takes n by 2 operations. So now, do we call the complexity order of n by 2? No, we don't. Because we will basically generalize whatever it is to the higher order term. Right. So by higher order term, I mean you guys must be knowing about polynomials, right? So if there is ax plus bx square plus cx cube, something like this is basically the higher order term in the polynomial, right? So what we do is, if there is a order of something like this, sorry, yeah, if there is like order of something like this, we generalize it to O of x cube, because this is the higher order term, and we basically ignore whatever constant is there, and whatever smaller order terms is there, we ignore all of them, and then generalize it to the higher order term. So in this case, we ignore this constant, whatever it is there, we call the complexity order of n in worst case. Okay. Nihesh, it's not 2 power n because like this is like in worst case it will only run for like n by 2 times. If say my n is 10, the code will like yeah the code will start from 0 and take 2 jumps every time. So 0, 2, 4, 6, and 8. This is like the code will actually run for 5 times only and not really 2 to the power of 10 times. So yeah, that's that. Okay. Cool. You guys got this point, no? Key we will generalize it to the higher order term. Please give me a thumbs up if you got it, please. Yeah, thank you. Last year, Priya, you can, if you have any doubt, you can ask it in the chat box. Like whoever is raising their hands, if you guys have like any doubt, you please feel free to interrupt me in the middle and get it cleared then and there. Okay. Yeah. Okay. Yeah. Let's move on to the next question. Hmm. Now, please tell me the complexity of this code. Order of n square. Nice, nice, nice. Very nice. Yes. Yes. Correct. Nice. Right. Hmm. So by the looks of it, what happens over here is the outer loop is running for n times, but then the inner loop is starting from I plus 1, right? It's not starting over from 0, right? So it's basically something less than n square. By the looks of it, we might feel like the complexity of this must be something less than n square, and it's definitely not n square, right? So by the looks of it, that is how it might feel. And also, please take a look how to calculate the calculate the time complexity of a particular code. I will explain it to you through this example. So what happens over here in this example is the outer loop runs for n times, and the inner loop starts from I plus 1, basically the outer loop plus 1, right? So let's take I is equal to 0, right? When we, now if I is equal to 0, the inner loop the inner loop starts from 1 and goes till n minus 1. Actually, it's less than n, so it goes till n minus 1. So your j starts from 1 and goes till n minus 1. So that basically means that it takes n minus 1 operations on a whole for I is equal to 0. And for I is equal to 1, j will run from where? J is I plus 1. So j is basically 2. And it, of course, goes till n minus 1. So that is n minus 2 operations on a whole for the inner loop. And so on, of course. This will go on up to I is equal to, say, for let's say I is equal to n minus 2. J will go from n minus 1 to n minus 1. It's basically only one iteration. So this is just one iteration. And for I is equal to n minus 1, 0. 0 iteration. Yes, Bharat. Of n square plus n, you generalize it to of n square, not of n. You got close there. It's probably a typo or something. I don't know. Okay. Yeah, that's nice, Bharat. Okay. Yeah. So if we add up all these operations at the end, now what happens is it's basically 1 plus 2 plus so on up to something like n minus 2 plus n minus 1. Right. And I hope all of you know what this formula turns out to be. It's basically the sum of n minus 1 natural numbers. And that is basically n into n plus 1, but then n is here n minus 1. So n minus 1 into n minus 1 plus 1 by 2, minus 1 plus 1 cancel. So that is basically n into n minus 1 by 2. So this is order of n into n minus 1 by 2. So what? Complexity is order of n? No, not really. Because we expand the term. As I told you, we expand the polynomial. So it's n square by 2 minus n by 2. And the higher order term is n squared over here. So we say that the complexity of this code is order of n squared. Right. So now whatever code is given to you, just see your complexity purely depends on the loops, right? For now, at least, your complexity purely depends on the number of loops that take place, right? So, so what happens is whenever you're trying to calculate the complexity, just take a very careful look at your loops. Figure out what is the maximum number of operations. Yes, Bharat, correct. Yeah, what is the maximum number of operations that might take place, and that is how we basically uh, estimate a time complexity. Okay, cool. Now, what is the complexity of this code? Order of n, we got our first answer. Order of 2 power n. Okay. Order of 2 power n seems to be the right answer, I guess. Any other answers? Order of log n. Okay. Okay. Any other random guesses as to be as to what this will turn out to be? Order of n. Okay. Order of root n. Okay. Hmm. 2 power n by 2. Any other guesses? Order of n. Hmm. Okay. Let's see. Now this loop basically starts from 1 and goes till n, and it multiplies itself by 2. Yeah, it multiplies itself by 2 every single time. Let us assume that my n for now is say 10. Okay. So how this loop exactly runs is, it runs for I is equal to 1, and then it multiplies itself by 2, hmm, and then it becomes I is equal to 2. It multiplies itself by 2, it becomes 4, and then this becomes 8. And this is where the loop terminates, because for I is equal to 16 the condition is not met, and this is where the loop terminates. It's because it's greater than 10, right? So now the number of operations it took is 4 operations. So what exactly is this for? Now let's try to generalize it for any n. Okay, so what happens is, I start from I is equal to 1, I go from I is equal to 2, like I is equal to 4, and then some operations ke baad I will reach some I is equal to what exactly is this? It's one. This is 1 into 2. This is like, sorry, this is 1. This is 1 into 2. This is basically 2 into 2. This is and then the next thing is 2 into 2 into 2. It's basically 2 to the power of something. Yeah. So the ith term is basically 2 to the power of something. Let us say this term is 2 to the power of k, and this is where I end my thing. Okay. Like this I is equal to 2 to the power of k is the last iteration of my loop, and in this case it's basically 4, right? Because at I is equal to 2 to the power of 416 I end, right? So I can safely say that um like I can say that 2 to the power of k is greater than n, right? And I can say that 2 to the power of k minus 1 is less than or equal to n. Is this statement true or not? Yes or no? Give me some reactions. Yeah. And I can say that this k minus 1 is the highest term such that my number of operations, like my I stays less than or equal to n. So this k minus 1 is basically what I'm trying to find out, right? Because this is the number of iterations. In this case, it was 4, right? At I is equal, in this case, in the above case, it was 2 to the power of 4, and it happened to be executed for like 4 times, because 2 to the power of k minus 1, which is 2 to the power of 3, is less than or equal to 10, right? So now that 2 to the power of k minus 1 is less than or equal to n, what I will do is I'll apply a binary logarithm on both sides. I'll apply log 2 on both sides. I hope you know this property of logarithms called, like, if log a to the power of b is equal to log b times logarithm of a, right? So now that I apply logarithm on both sides, this is k minus 1 times logarithm of 2 is less than or equal to logarithm of n, right? So, and I will actually eliminate this less than or equal to, as I am trying to find out k over here, and I'll generalize it to equal to, right? So k minus 1 is, and log n by log 2 can be generalized to log n base 2. This is some mathematics. I'm so sorry, I'm bringing mathematics over here, right? And I can say that k is approximately equal to 1 plus log n to the base 2, and then again higher order term, the order of k is equal to order of logarithm of n to the base 2. So the complexity of that particular code is order of logarithm of n to the base 2. Um, I saw a lot of order of logarithm of n answers, which is very nice. Right. So this is the trick, people. You just have to see generalize as to how many worst case operations your code is taking, and then you have to find a way to figure out those number of operations. So that's about that, right? Okay, now let's see about this one. This is the last question, like in this time complexity thing. What is the time complexity of this code? Any random guesses? Out of n squared. Close, okay. N squared. Mm-hmm. Any other answers? Mm-hmm. Just try out this method. Dikshita says order of n. Okay. Yeah. So basically, try out this method. Whatever I told you, what is like the maximum number of operations that it's going to take. See, estimate as to what that number might be. Order of n squared, order of log n, order of n, order of n log n. Hmm. I would really love to wait for a little longer for the answers, but then we are actually kind of running out of time, so I'll explain it to you guys. Now, now this loop will definitely run for n times. Okay. Now this loop like will definitely run for n times no matter what happens on Earth, right? So the complexity can never be lower than O of n. That much we're figured out. So the complexity is definitely not less than O of n. That much we figured out. Now the part which is interesting is this part. J starts from 1 and J goes on until n, and J takes I steps every single time, right? So what happens in this code is the outer loop, it runs for n times, no doubt in that. Now what happens in this loop is for the first iteration when I is equal to 1, J plus is equal to 1, and like this entire thing runs for n times. Okay, no doubt. Next, so when I is equal to 2, J is equal to 1, J less equal to n, J plus equal to 2 here. So half will be gone. Like half iterations are like gone now. So this loop will run for n by 2 times now that we are skipping 2 every time. This is n by 2. Okay. By the way, I'm so sorry. This like it's not this. This I'm okay. For I is equal to 1, this thing will run for n times, and for I is equal to 2, this will run for n by 2 times. Now for I is equal to 3, let's see how many times this will run. J is equal to 1, J is equal to n, J plus equal. Yes, yes, correct. N is and yeah. So this will run for n by 3, so on up to it will basically tend to something, right? So now the thing is, I will take n common, and this will turn out to be 1 plus 1 by 2 plus 1 by 3 plus so on 1 by 4 or something like that, right? So now what does this equal to? So this I'm expecting. I mean, all of you are from MPC background. So what is this called? Does anyone know what is this thing called? What is this series called? Anyone? So some progression it is called, no? HP. Nice. So yes, correct. This is harmonic progression. This is a harmonic progression, and this will approximately tend to some logarithm, right? Yes. And this will approximately tend to some logarithm. I don't remember the formula. There is like a long as formula, which is not really necessary, but then it's important to know that this will basically tend to a logarithm, right? So we can safely say that the complexity is n log n in the worst case. This might tend to anything, but then it won't go greater than log n base 2. So we basically say that the complexity of this particular code is n times logarithm of n. Cool. Yes. Nice to see. Nice to see those answers. Nice. Yeah. So the complexity of the code is n log n. Okay. Nice to see those answers. Right. Okay. So that's that. We're done with the examples. Let's go. Hmm. Yeah. So now that we're done with examples, this is basically a cheat sheet of required time complexity of this thing. Okay. I did not. Oh wow, great. Hmm. Yeah. So what actually happens when you run your code on an online judge is now that we've seen the number of operations that your code might take, let us see how an online judge works, right? So you basically write your code and then you submit to an online judge like some code forces or code chef or something, and it gives you a verdict as to your solution is correct or not, like correct or not, did it pass the time limit or not. It's something like that. Your code is given these verdicts. If your code does not pass the time limit, it gives you a time limit exceeded error. How many of you have actually got this time limit exceeded error? Give me a thumbs up while coding questions. Yeah, so many people. Now let's see why this time limit exceeded errors happen, right? So what your online judge, like what a processor, 1 gigahertz processor is capable of is it can run 10 to the power of 8 operations per second, give or take approximately. It can run up to 10 to the power of 8 operations per second. Okay. Now, let's take a very, very simple example. Okay. Now, I gave you an array of integers, or rather, not array of integers. Now, I give you a problem. I will give you n. Okay. I'll just give you a single integer n, and I want you to find out the sum of all the natural numbers up to n. Okay. Now, what happens is if my n is up to 10 to the power of say 5 or something. Now, what I can do is naively I can say I can initialize some variable in sum is equal to 0, and then I can go from I is equal to 1 to n, and then I can say sum plus is equal to I, and then I can print the sum. As simple as that. Nothing brainy, no brainy stuff. So, what is the complexity of this approach? Now, if I code it in this way, what is the complexity? Sum of n natural numbers using a loop. Yes, correct. Order of n, because in the worst case it takes in iterations n operations, right? Order of n is the complexity, right? So now I know for a fact that my n is 10 to the power of 5. So this might go up to 10 to the power of 5. So order of n. So this will take 10 to the power of 5 operations. My entire code will take 10 to the power of 10 to the power of 5 operations, which is okay with the compiler. And usually these compilers like have like 1 second of time limit, right? And my 10 to the power of 5 operations is very less than 10 to the power of 8. Definitely good, very nice, anta bagundi. Okay. Now what if I say my n will range up to 10 to the power of 15, not 5 this time, 15. Now what happens when my n ranges up to 10 to the power of 15 is now my complexity, like the number of operations that I may take is 10 to the power of 15 operations. Okay. Now my I know for a fact that my processor takes 1 second to run 10 to the power of 8 operations. Now, how many seconds will it take me to run 10 to the power of 15 operations? Anyone? 2 seconds. Jashwant says it's true. Anyone else agree with him? 5 seconds. 10 to the 7, 10 to the 7. Correct. So it basically takes 10 to the power of 7 seconds to run 10 to the power of 15 operations in this case. So 10 to the power of 7 seconds is a long ass time. And trust me, you don't want to spend 10 to the power of 7 seconds to find out what sum of natural numbers up to 10 to the power of 15 is. Right. So obviously this won't work, and this order of n approach will definitely not work, and it will give you an error called time limit exceeded. So you got it. This is how time limit, like this is how time limits are judged based on the worst case number of operations. You see how many seconds it will take to execute your code on approximately, and you say if that is going to give you a time limit exceeded error or not. Now in this case, if I want my code to pass, whenever I give you like some n and then I need sum of n integers, what might be valid? What might be a valid approach to? Yes, correct. Yeah, so there is a direct formula, right? for n sum of n natural numbers. It's just n into n plus 1 by 2. And printing n into n plus 1 by 2, this will basically take order of 1 time. This is nothing. Okay. Yeah, correct. So you are basically reducing the entire thing from order of n to order of 1. So this is basically n times faster. Your approach is this approach is n times faster, and you've seen that you've saved yourself 10 to the power of 7 fucking seconds. Okay, cool. Now, yeah. So let's look at this one. Yeah. So this is basically a cheat sheet as to what complexity works for what, right? So if the input size is less than or equal to 10, less than or equal to 10, like n factorial thing works because 10 factorial is way less than 10 to the power of 8, right? So when n is up to 10 to the like when n is like up to 500, n cube solution also kind of works, but it might be a little tight. Right, so it kind of exceeds 10 to the power of 8, but then you can safely assume that 1 second it takes 10 to the power of 8 or approximated some 10 to the power of 9 operations, something like that. Okay, so yeah, for sorry, it's 10 power 6, right? Yeah, so yeah, you can safely assume that for n less than or equal to 500, n cube safely passes. And for n and also for n is equal to 10, any of these approaches will work. It's just that this is the bottleneck. You can't go higher than n factorial for n is less than or equal to 10. And for n is less than or equal to 20, you can only go up to 2 to the power of n, but you can't code a solution which whose complexity is of n factorial. And same thing when n is less than or equal to 10 to the power of 6, you cannot code a solution whose complexity is of n squared, because this will become of 10 to the power of 12, which is like which exceeds 10 to the power of 8 in a way. So this is basically a cheat sheet. If you want, you can take a screenshot of this, or it's just easy to. I mean, it's a simple mathematics to do it anyway. And also, I hope you're taking notes. This might seem a little lame, but yeah, notes helps. If you want to take notes, if you're a person who likes to take notes, you can as we go through, or it's just your wish. It's just that we tend to forget this information later on if you don't apply it anywhere. So it's better if you note it down. Right. Cool. Now, yeah, let's skip to the next part. Data type analysis. Hmm, we will go through this very quickly. Um, so integer range in C and C++ is basically up to -2 to the power of 31 to 2 to the power of 31. Whatever exceeds this limit cannot fit into integer. That I guess you all know. And 2 to the negative 2 to the power of 31 to 2 to the power of 31 minus 1 approximately lies in the range to -2 into 10 power 9 times 2 into 10 power 9. Okay. So whenever you see 10 to the power of 9, it's basically in an integer limit, right? So long integer range in C and C++ is basically -2 to the power of 63 to 2 to the power of 63 minus 1, and this approximately equals -8 times 10 power 18, 8 times 10 power 18. Why am I telling you all of this shit? You will know soon. And integer in memory is basically 4 bytes, and you can derive this information whatever is written over here, and this you need to remember anyway. I'm so sorry about that. And whatever information that is provided to you over here, that you need that you can derive, but then it's better to remember it anyway because it's so easy. And the maximum boolean array size that you can declare is 10 to the power of 18, sorry, 10 to the power of 8. Maximum integer array size that you can declare is 10 power 7, and maximum long int array size that can be declared is 10 power 8, because like this is almost like long int in memory. It takes 8 bytes. Like it is double the memory. It takes double the memory as integer. So this is the approximation as to how like what is the maximum size of array that you can declare. Right. So this is about very small data type analysis. Now, what I'm going to do is I'm going to show you guys a few questions, and then we'll see about how to go about solving those questions. Right. Give me a second, please. How do we get the logic or approach to optimize our solution? Because even yesterday there was fourth question which gave TLE, but I couldn't reduce time complexity. Reducing time complexity is something like very different. For reducing time complexity, I'll explain it to you. One second. Give me 1 second for this. Yeah. Yeah. So coming to a question right now, Mudit. The thing is to reduce time complexity, we can one thing is we need to be like very good at implementation. Okay. Whatever you're implementing in the language, you need to know some stuff beforehand. So like say okay, one example that I can give right off bat is say you are applying some algorithm like linear search on an array, right? You know for a fact that sometimes it might not work, and you might have to switch to binary search, right? So in that way, the time complexity comes down from of n to of logarithm of n, right? So you need one thing is you need to implement well, and the second thing is you need to know some algorithms in beforehand, right? So if you know those algorithms beforehand, like how binary search works or whatever, I'm just taking a very random example, but then if you know for a fact that like this algorithm exists and this is how I can do it, that might help you reduce this TLE problem. And I'm the more problems you solve and and more tricks you learn, you will like you the more experience you gain in reducing questions, like reducing time complexity in the questions, right? So what I would recommend to you is like to practice well, and then learn some algorithms. Like if you're not able to reduce time complexity now, just take a look at how the problem was solved in the first place. Yeah, we will, yeah, we will, Rehan. Yeah. Met Tempa 9. Sai Karthike, I did not really get the question. I mean, the limit were till 10 to the power of 9, which does it mean that like the array elements were up to 10 power 9? Uh-huh. We need to include a condition. Ah, Asha, okay. Yeah. So these questions. Okay, wait. Okay, fine. Integer overflow I will cover in a few minutes. So, Karthike, the thing about questions like that is mm, you know what? I'll actually cover this integer overflow thing, and I'll come back to that question, Karthik. I did not really understand in the entire thing what which is happening, but then once I cover this integer overflow thing, I'll come back to this question. Right. So okay, let's see this question. Now, given an array of n elements, print the elements in it in a sorted order. Okay, this is the question. Nothing fancy. So some elements are given to you. N is up to 10 to the power of 5, and a of I is up to 10 to the power of 18. And then you are required to basically print the sorted array. There's nothing really fancy in this question, right? So now what happens is usually when we see these kind of questions, we tend to code some algorithm which works, right? So now that now say I'm a layman, I do not know anything about these constraints. I will think that bubble sort might also work, right? Let's see. Right. So I basically coded a bubble sort. Yeah, I basically coded a bubble sort algorithm for this particular question. Right. So we know for a fact that the complexity of this code is order of n square. Right. Uh, so now if I run this code, this will pass very well on my sample test cases. Like the sample test case, which is very low, will automatically like very easily get passed. But then when I submit the code, I will see something like time limit exceeded or terminated due to timeout, whatever. So this code basically takes more than 2 seconds to execute, and this is why I get an error called terminated due to timeout, because I'm using bubble sort and the complexity of this code is order of n squared. Now, now to all those people who do not use C++, I can basically just replace this line with sort a comma a plus n, and this will basically sort my array in order of n log n time. It's really as simple as that. So switch to C++ as fast as you can, right? So now when I run this code, it will run really fine. Now, how many of you say that this particular code will get an accepted on submission? Okay, provided this is definitely in order of n log n. TLE is definitely not a problem here. Now, tell me if this code will give me an accepted solution if I submit it right now. Yes or no? Hmm. Let's see. I hope you've read the constraints very well. I'll show you the constraints. I mean, yeah. So look at the constraints once. Now tell me, will this code get accepted? I mean, if upon submission, how many of you say yes? Give me a thumbs up. CSEC, please stop spamming now. Thank you. Hmm. No, but the thing is, when I submit this code, this will give me a wrong answer because I am trying to read an integer. I'm trying to read an integer array, but then my elements are up to array elements are up to 10 to the power of 18. So as I've mentioned already, if the element is up to 10 to the power of 18, integer limit, it will definitely not fit. And I will have to convert this thing into long integer. Only then will it work. Now when I submit this code, it should get me an AC. Right. So please take a look at the constraints beforehand of solving any question. Just please take a look at those constraints. Right. So everyone, please read this question. I'll give you 2 minutes of time to read the question. And if you're done reading the question, please give me a thumbs up in the. Or rather, I'll just post this in the chat box so that you can guys you can access it directly. Right. Yeah. So okay. Yeah. So now in this problem, what it says is there is a guy called Ereniega, and then he adopts a parrot which says either only odd or even. The parrot only says odd, or the parrot only says even, right? And the parrot basically speaks only b times a day. Okay, and then b times it either says odd or even. And Eren also has an array of n integers within. So what he does is, firstly he takes a variable and initializes it to 0. Okay, and then when the parrot is odd, he adds the sum of all the odd integers in the array to the sum, to whatever this is sum. And whenever the parrot is even, he adds the sum of all even integers into the array, into this variable called sum. Right. Now, let's take a look at this example and see what happens. Now, so Aaron has an array called 1, 2, 3, 4, 5. And also, I'll explain you the input format real quick. So in input format, n is given first, the number of elements in the array. And then second line of input, it contains basically all the elements of the array. So this is the size of the array which is given first, and this is the entire array that is given. And then the next line is basically b, the number of times the bird will speak, right? So the number of times the bird will speak, yeah, cool. So and then next and three lines follow, like three lines of input follow each day. Like on day one, it's the birds is even, on day two the birds is odd, and sorry, first time the birds is even, the first second time the birds is odd, and the third time the birds is even again, right? So the explanation to this is given over here. Now, on the first day, when the bird says even, right? Bird says even. We add all this sum of all the even integers into our sum, right? So sum is initially 0. Sum the Aaron adds 2 plus 4 to the sum. So the sum becomes 6 now. Now, when the birds is odd, Aaron will add all the odd integers into the sum, right? So, like this thing was usually 6. The sum variable was initially 6, and then Aaron adds 1 plus 3 plus 5, which is equal to 9, to the results in sum, and 6 plus 9 is 15. The new sum is basically 15, right? The last time the birds is even again, so Aaron, what he does is he adds 2 plus 4 equals 6 to the resultant sum, and then 15 plus 6 becomes 21. And at the end, we are required to print 21, the entire thing. Okay, I guess you're all clear with the question. If the question is clear, please give me a thumbs up. Okay, thank you. Yeah. So now, how do we go upon coding this question? Now, if I were to write a simple brute force approach to this question, it would look like it would look something like this. Hmm. Now, based on the and also based on the input format only, you're supposed to read these integers. Now, 5 comes up first, so I will read n, like the size of the array first, and then I will read the entire array because that comes next. Okay, so nothing fancy. I read an integer, and then I read the array. I read the entire array, and then I read b, how many times the bird speaks, and then I initialize sum to zero, as Eren does. I will initialize sum to zero, and for every b, like for int I equals 0, I less in b I plus plus. Now, when I'm supposed to read this particular string, there is a data type called string in C++. You don't have to declare a character array, and then you don't have to explicitly read that character array as in C. C++ gives you a very nice utility called a string, and you can directly scanf percentile as this thing, string as and scene as. And then if s is basically even, what happens is I will loop through the entire array, and then I will see if an element is even, and I will add some, like I will add that thing to I will add this element to the sum. And similarly, if s is basically odd, what I'll do is I'll loop through the entire array, and then I'll check if the element is odd, and then I'll add the odd element to the resultant sum. And then after all the b operations are done, I will directly see out sum. Okay, nothing fancy in this particular thing. So can you guys please quickly tell me what is the complexity of this particular code? Like, what is like the time complexity of this particular code which is being shown on the screen? N squared. Okay. Okay. NB. Okay. Yes. Yes. Correct. Correct. So let's see. Now, so what I did is in this particular code, first I took an integer and then read this entire thing. So that is basically order of like n for reading plus because the reading operations is it's done, and I'm not multiplying it to anything, right? And next, for b times what I am doing is I am iterating over n, like, yeah. So for every b times I am iterating over all of n, right? So this takes b times n. Okay, so the complexity is basically order of n plus b times n, but then we'll be what do you call that, generalizing it to the higher order. So the complexity of this code is basically n times b, order of n times b. And also it is given that 1 is less than or equal to 10, n is less than or equal to 10 to the power of 5, and 1 is less than or equal to b is less than or equal to 10 to the power of 5, right? So b can be easily compared to n. So I can say that the complexity of this entire code becomes order of n square, approximately. The complexity of this entire code is order of n squared. Okay. Now, if I submit this code, what will happen? What is most likely to happen? Anyone? If I submit this code as is without changing anything, what is most likely to happen? Runtime error. Okay. Timeout. Yes. Correct. 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 Yeah. So this will basically throw me a TLE, time limit exceeded error, or terminated due to timeout, because the complexity is obviously more than, I mean, the complexity is order of n squared, and n can be up to 10 power 5. So yeah, this should give me a terminated due to timeout, and it did give me a terminated due to timeout. Now think about what can we do to make this even better. Can someone tell me how do I? Mhm. Yes, Rehan, correct. Yes, even count times even sum, the short term. Yeah, hashing. Okay. Yeah, Rehan and Kaushik, you guys are right. What instead what we can do is now the problem. And one more thing is, Mudit asked me how to eliminate TLE from the codes, right? Now, what I usually do when I want to eliminate TLE from my codes is I see what is causing TLE. Now, listen, this loop is inevitable that I should put. I will see what loops I can eliminate to eliminate my TLE, right? So this loop is inevitable. This for int I equal to 0, I less than b, I plus plus, this loop is inevitable. I can't really, I can't skip this loop. I have to run b times. But then the problem is I do not really have to, due to this particular loop, the complexity of my code becomes order of n square. Because of this loop, the complexity becomes order of n squared, and this is the main culprit here. I somehow have to eliminate this loop and write a better logic, right? So now, instead of looping this entire thing altogether, what I can do is I can pre-calculate the sum of like even elements on top of here, and pre-calculate the sum of odd elements on top of here. And whenever s is equal to even, I can just say sum plus is equal to some that even sorry, that even thing. And then whenever s is equal to odd, I can say that sum plus is equal to odd sum. I'll show you. Yeah. So I will initialize two variables called odd sum and even sum on top of here. And then while I am reading this entire array, if a of I is odd, I will say odd sum plus is equal to a of I, or else I'll say even sum plus is equal to a of I. Now what happens after this loop is, now for this particular test case, after I read my entire array, my even sum becomes 6, and my odd sum becomes 5 plus 3 plus 1, 9. Right. So for every iteration, I don't really have to loop through the entire array to find this even sum and odd sum. It won't change in the array anyway. So I'll just add it, and that's all. Simple. For int I equals 0, I less than b, I plus plus. I read the string, and if s is equal to even, I'll say sum plus is equal to even sum, or else I'll say sum plus is equal to odd sum, and then I will say odd sum. No, if I submit this code as is, will it give me an AC? Yes or no? Please type it out in the chat box. And if it is a no, why is it a no? Okay, nice. Hmm. Yeah, integer overflow, right? So now let's see why this thing actually goes to an integer overflow. Now, see, you always have to check about TLE. You guys always have to check if your code gives TLE or not, and you also have to check if your code gives wrong answer or not. Also, if your logic is particularly fine, and your code is not giving TLE and it's still giving a wrong answer, it's probably because your variables are kind of overflowing somewhere. That might be the case, right? So all right. Now, why does this thing overflow? Let's see. Now, I know for a fact that B, yes, correct, Ritvik. Now, I know for a fact that B is up to 10 to the power of 5. Okay. Now, what I'm doing is, now in the worst case, let us say I have 10 to the power of 5 elements in the array. My n is 10 to the power of 5, and all the elements are, and I've given that all the elements are up to 10 to the power of 5, right? So all the elements are 10 to the power of 5. I have 10 to the power of 5 elements which are 10 to the power of 5. In this case, what is my even sum? Anyone? There are 10 to the power of 5 elements which are 10 to the power of 5. What is the even sum? Like what is the sum of all the even elements in this array? It's not really that hard to. Oh yeah, yes, Ritwik, you're right. Yeah, correct, correct, correct. Thank you for the responses. Hmm. Yeah, so your even sum becomes like 10 to the power of 5 is obviously even, right? So my even sum is like 10 to the power of 5 times 10 to the power of 5, right? Because my like I'm adding up 10 to the power of 5, 10 to the power of 5 times. This basically just multiplying it by 10 to the power of 5. So even sum is 10 to the power of 10, and my odd sum is 0. Right. Now, in the worst case, if for like for b times, if the bird says even, okay, the bird says even every single time b times for 10 to the power of 5 times. Now, what is my total sum? So for b equals 10 to the power of 5 for this particular array, and for this particular input for b is equal to 10 to the power of 5. If the bird says even every single time, what is the total sum at the end? Yes, b into 10 to the power of 10. And provided b is 10 to the power of 5, and sum is basically 10 to the power of 5 times 10 to the power of 10, which is 10 to the power of 15. Correct, Pavitra Antarani, you're right. Right. So this is obviously greater than 10 to the power of 9. This obviously greater than 20 to the 10 to the power of 9, and this is supposed to be changed to long log. So this sum variable is supposedly not only the sum variable, but both even sum and odd sum variables. These variables must also be changed to long log. Cool. So if I call these long long, and if I call this also long long, only then will I get an AC on the score. Yeah. So yeah, that's that. Okay. So yeah, that's about data type and time complexity analysis. The key takeaways that I would like to tell you guys is: point number one, always look at constraints. Yeah. So key takeaways is always look at constraints. Point number two, always estimate worst case time complexity and data type thing, your data type integer overflow, whatever, like integer thing, this thing. Okay. Always estimate, always look at the constraints, and based on the constraints, estimate your worst case time complexity and data type thing. Right. So the first and foremost part to solving any competitive programming problem is to do these two parts. This is where you basically start tackling competitive programming problems really well in the contests. Okay. So yeah, that is from my side for today. Nishita will take over from here. What happens if you use long int in every problem instead of int? Nothing is going to happen. You can actually use long int in every problem instead of int. Um, well, I would say that at this level, nothing is going to happen if you use like long int instead of like int in every single problem. But then when you get introduced to dynamic programming in future, sometimes you will have to declare an array size of 10 to the power of 7 or something. So something like that might happen, and whenever you declare a long int instead of int there, it will take a lot of memory, and it will give you a runtime error. For now, for your level, probably you can like use long int anywhere you want instead of int, which it will give you no problem. But then just make sure that you don't declare an array size which is like very large, that it will give you an runtime error when you do a long int instead of an int. Yeah. Any other doubts? I will be leaving, and Nishita will take over in after like we're done with the doubts. And so if you guys like have zero doubts, I will be leaving. Is Python a good language for CP? It actually is a very good language. For competitive programming, I'd say if I were to rank C++ and Python for competitive programming, I'd say C++ right off the bat. Because what happens in Python is if you do competitive programming in code forces, especially now there is this thing called time scaling policy in code forces, right? Sorry, there is no such thing called time scaling policy in code forces. Now, what happens is if we rank these languages based on speed, there's C++, Java, Python. If a code takes 1 second to execute in C++, it takes 2 seconds to execute in Java, and then it takes 3 seconds to execute in Python. Python is that slow. Right. So, what usually you would like what usually happens in code forces is now every question will be given a time limit of 1 second. So you will have no choice but to optimize your Python code. Like if you write the same logic in C++ and Python, sometimes C++ will give accepted, and then Python might give DLE. I'm not telling you that in every case this might happen, but then in when you do like very tough questions, this might happen. The very implementation heavy questions, this might happen. And this problem is usually only on code forces, but then on CodeChef and HackerRank or whatever, what happens is like the time limit for C++ is 1 second. Time limit for Java is multiplied by 2, and time limit for Python is multiplied by 3. So you don't face these problems on CodeChef and HackerRank or whatever usually, but then you or Atcode or whatever usually, but then you find this problem on code forces. Key Python is usually slow. You'll have to optimize your codes more in Python when you use Python. So apart from that, like if you're okay with that, if you can definitely go with Python, or else you can just go with the popular opinion and learn C++. Did that clear your doubt, Anitej? Cool, cool. So any other doubts, people? Okay, so that's been my thing. Now I'll let Nishrita take over.
Hello, people. So you guys have been listening to a lot of theory stuff and all of that since so long. You guys must be a little bit bored or something. So now let's get on to problem solving. So I expect you guys to react and give solutions to the problems instead of me just telling the solutions out. Let's keep it interactive, guys, so that this long session won't get boring. So, a second. Okay. Chalo. So let me give you a problem first. Okay. Uh, so you're given an array. You're given an array of integers. Say 1, 2, 5, 6, 3, 4. Okay. So this array denotes the amount of water that each plant requires in order to like it to feel completely like energetic and all of that. Okay. So this array is the like I gave you an array, and each element in the array, the first element denotes the amount of water required by the first plant to feel energetic types. Okay. So now you have X amount of water. Say you have 10 liters of water and 10 liters of water. Okay, don't go into the logics and all of that. Okay, so 1, 2, 5, 6, 3, 4. You have 6 plants, and plant 1 requires 1 liter of water, plant 2 requires 2 liters of water, 3 requires 5, so on, and you have 10 liters of water. In one day, what are the maximum number of plants you can water such that all of them feel energetic? This is the question. Did you get the question? Just react with a thumbs up if you're clear with the question. uh, if you did not understand the question, just drop it in the chat box, or react with a thumbs down or something, or just raise your hand. I'll explain it once again. uh, this is basically not the, I mean, I'll drop the other questions here, but then there is no link to this question, so I'm explaining it orally. Shall I explain the question once again? Okay. So there is an array, and each element in the array, the ith element, denotes the amount of water required by the ith plant for it to feel energetic. Okay, so I have X liters of water, and I can give them to like any plant that I want randomly. So what are the maximum number of plants that I can water with the X amount of water that I have is the question. Is the question clear now? Okay, cool. Can I get this like your approaches to the question in the chat box? Just the approach. Okay, sorting what exactly? Sort and count till the water completes. Okay, cool. Sum of first in first. Okay, in whatever numbers which equal to X. Cool. Okay. Sort the array and increase the count until less than X. Cool. Okay. Yeah, most of you have the approaches right. What you generally do is you just sort the array according to, like, you just sort the array in increasing order 1, 2, 3, 4, 5, 6. And then initially my water count is 10, so I can water this plant, so it becomes 9 now. Now I can water this plant as well because I have 9 more liters of water, it becomes 7. And then I can water this as well, it becomes 7, 6, 5, 4. And then I can water this as well. And my water becomes 0 here. I cannot water any more plants further, so my answer will be 4. Okay, so we for a fact know that if we sort and like this is the most optimal approach here. Like if you sort and if you take the elements, if I start off by taking 6 to, I'm like, if like there is a possibility that I can take 5 3 2 1. Wait, I mean, I'm sorry. Can I take like 1 2 3 5? No, you can't. I mean, this is the best possible answer, and you're sure that This is the best possible answer. Like watering 4 plants is the maximum amount of plants that you can water. And it is always optimal to take the water, like the plant water the plants that take minimum amount of water, because that costs that costs the least, and that is the optimal thing that you can do. So you for a fact know that this is the direction you are going, you have to go in order to get an optimal answer. Okay, so let's go to another question. Okay, I'll drop this in the chat box first. Okay, cool. So I dropped the question in the chat box. You can just go through the question. Okay. So the question is, Sasha decided to give his girlfriend an array. Okay, don't get overwhelmed. Okay? It's just a question. Okay. Given girlfriend an array, he found out that his girlfriend evaluates the beauty of the array as the sum of the values of ai minus 1 from for all integers from I for I belongs to 2 to n. So basically, read the question. Okay. So the question is, you need to find out, basically you can rearrange the array in any way that you want to. You need to rearrange the array in such a way that the summation of ai minus 1 is maximized, where I belongs to 2 to n. And this is a one based indexing, like the element starts from a of 1 and not a of 0. So is the question clear for all of you? You need to find out you need to rearrange the array in such a way that the summation of ai minus 1 for all the elements in the array is maximized. Is the question clear? If the question is clear, please let me know by reacting to it with a thumbs up. Okay, take some time, people. I'll give you 2 minutes of time. Just give me your approaches in the chat box for this. Sort in increasing order and use a loop to find the difference between adjacent values and sum them. Okay. Okay. Cool. Any other answers? Highest minus lowest. Cool. Max minus min. Cool. All of you have the right, almost each one of you gave the right answer, but do you exactly have an idea of why that works? I mean, obviously, if you sort the array, if you take the adjacent differences of adjacent values, it will work. Or if you take the highest value minus lowest value, it will work. But can someone write down why exactly that thing works? Like a statement of proof or something like that? Okay, cool. Let me list. Okay. So, like basically what he wants us to find is, yeah, cool. Vamshi is already with the answer. Sum of adjacent values in array will be maximum in sorted array. Cool, that makes sense too. To maximize the beauty, the difference should be maximum. Cool. Yeah. Other than max and min, all the other elements gets cancelled due to repeated addition and subtraction. Cool. Nagajanvi, cool. Yeah, that is the intended answer to the question. So say you have A1, A2, A3, so on, so till AN. This is your array. So what he is asking us to find out is A2 minus A1 plus A3 minus A2 plus so on, so till AN minus 1, right? So here A2 gets cancelled, A3 gets cancelled with the next term over here, and AN minus 1 gets cancelled with the term over here. So what we are left with is, we are left with AN minus A1. So in order to maximize the beauty of the array, what you need to do is you need to maximize the value of AN minus A1. It does not matter what elements you keep in between, you need to maximize the value of AN minus A1. So optimally, what is the best thing that you can do? You can put the maximum value over here and the minimum value over here, because obviously subtracting the least number from a number that is very high will give you a greater number, right? So maximum minus minimum, maximum of the array minus minimum of the array will be the answer to this question. Cool, done. Let's move on to the next question. And yeah, okay. uh, I shared another question in the chat box, just go through it. You can parallelly try it as well. Also, I'd be happy if you will share the links to your solution in the chat box as well. Okay, so are you guys clear with the question? So the question is, you will be given three values. The first one is A, B. He'll give you three values. Okay. Rachakunda Nihesh is like intro plus extro plus uni by 3. Okay. Okay. Uh, Nihesh, what if extro plus uni is not a perfect multiple of 3? Got the question? Then add 1. Is it 1? Also, will extro plus uni by 3 always work? Is it? Okay. Okay, I'll give you a test case, Nihesh. Can you just tell me your answer for this? What is your answer for this ideally? Nihesh, this is the introvert count, this is the extrovert count, and this is the universal count. Pavitra, same goes to you. Just let me know your answer for this test case. We can't fulfill, right? Yeah, Rutvik Maturu is like, we can't fulfill. Yeah, exactly. Can you give the numbers in chat? Like, the introvert count is 1, the extrovert count is 2, and the universal count is 0. 2 tens, yeah, we can't. We can't because extrovert has to definitely be in a tent with 3 members, or else it won't be fulfilled. So you get the edge case, right? Cool. So everyone's clear with the question, right? An introvert can only be in a tent with 1 person each. An extrovert has to be in a tent with 2 other members. That is, an extrovert can be in a tent consisting of 3 members each only. A universal person can stay in a tent containing of 3 members or 1 member. Okay. So this is the question. So what are the minimum number of tents that have to be used in order to accommodate all of them is the question. And if it is not possible to accommodate all of them according to their interests, you need to output -1. This is the question. You guys have given the answers to the question, but then you guys are missing out the -1 case where all the extroverts won't be able to fit in, like all the extroverts won't be able to fit in with 3 members each in a tent. So that is the case where you're missing. Any other solutions, people? Pavitra, even your solution goes wrong over there. Okay, so shall I discuss the solution for this? Or do you need time? Extra less than 3 and uni equal to 0 -1. Okay. Is it only extra less than 3? Is it only for extra less than 3? I'll give you an like for the same test case where my screen is visible, right? So introvert, like the introvert count is 1, the extrovert count is say 5, and uni count is 0. What is the answer for this one? If C less than 2 star B percentage 3, then -1. If extra is less than 2, then uni less than 2, extra percentage 3 not equal to 0, and uni equal to 0 -1. Okay. Only if uni equal to 0 is it -1? Nihesh? Is there no other possible case where it can go to -1? You might have a reminder of like you might have a remainder of 3 in the extra, I mean like 2 in the extra, that means you need oh sorry, you might have a remainder of 1 in the extra, that means you need 2 more people from uni, and you have uni equal to 1. Is that not a -1 case as well? If extra plus uni percentage 3 not equal to 0, and extra less than 3, then -1. Not exactly, Pavitra. If extra percent, are you guys randomly spamming solutions now? Okay. Uh, okay. So let us see. Like, I mean, you guys are close enough, but then you guys like there are edge cases that will go wrong in each one of your solutions. So let me just discuss the solution for this over here. So say the firstly, what we need to do is we need extra percentage 3 plus uni percentage 3 less than 3 then -1. Okay, so let us discuss the solution now, I guess. So first, it is our priority to accommodate the extroverts in tens of 3, because for universal people, there is a choice of either keeping them alone or keeping them in the tent of 3, right? So first, we'll try to accommodate all the extroverts in tents in which each member like each member is accommodated, a tent in which 3 members are accommodated. Okay. So the number of 10, okay, just a second. So let tens be the number of tens required. Let us consider the introverts to the last, because you just add the introverts count to the tens. There's nothing much to do with them. So coming to the extroverts, first you can you can group who like whoever are present in groups of 3, right? Now how many extroverts will be left? Extrovert is equal to extrovert percentage 3, right? These many extroverts will be left without any like they might be 2 or 1, obviously. 0, 2, or 1. If there is 0, uh, you need not accommodate any universal with the extrovert, because they're already paired like well enough. So the remainder here can be 0, 2, or 1, obviously, because when you're doing modulo 3, the remainders will be less than that number. So you can have remainders of 0 or 1 or 2. Now, if you have a remainder of 0, you need not do anything. If you have a remainder of 1, you need to accommodate this 1 from the universal thing, right? You definitely need to accommodate that thing from the universal thing. If you have one extrovert left, and you basically, if uni is less than the extroverts, now that is the leftover extroverts, it is a -1 case. Is everyone okay with it? If the number of universals is less than the, I'm extremely sorry, it's not extrovert percentage 3. Extrovert percentage 3 is the number of extroverts remaining, right? Now you need to find out how many more members you like to add. Let us consider that to be to add. What will be to add? If the remainder of extroverts is 0, you need not add anyone else to the tent, right? To the tent of the remaining extroverts. So it will be 0 if the remainder of ext percentage 3 is 0. If ext percentage 3 equal to 0, then 2 add will be equal to 0. If ext percentage 3 equal to 1, then it will be 2. You need to add 2 more universals to the tent, right? And if ext percentage 3 equal to 2, you will have to add 1 more universal to the tent. Is this clear, everyone? Is this clear? Ext percentage 3 only can only be in between 0, 1, or 2. And if ext percentage 3 equal to 0, you need to add 0 members. You need not add any members to the tent. If it is 1, you need to add 2 members to the tent, or you need to add 1 member to the tent. This is nothing but ext minus ext percentage 3. Mind you, this is not the original value of ext. Ext is the remainder, like after assigning all possible extroverts in tens containing 3 members, that is the remainder of the extroverts. So the extroverts remaining is ext over here, not the extrovert count that they gave in the beginning. Okay. So now, if if is 2 add is this one. Okay. Now we have computed the 2 add value. If 2 add is less than the number of universals, you can definitely not accommodate the extroverts according to their interest, right? So the answer will be -1 if 2 add is less than universal. Else what do? You accommodate, you subtract 2 add from the universals. Matlab, you add this guy, you add this guy to the tent in which there are 1 or 2 the remaining extroverts. So now the tens count will be, initially the tens count was, what was the tens count initially? It was extrovert by 3, right? Now we add this guy to the remaining the additional tent. So if uni is not equal to 0, only if only if 2 add is not equal to 0, we do tens plus plus. Okay. And then post this, you can now group the remaining unis in groups of 3, right? So now 10 plus is equal to uni plus uni divided by 3, because you can again group the remaining universals into groups of 3, because you need minimum number of tens. You can assign each of them to 1 tent each, but then since you need minimum number of tens, you assign them in groups of 3 first, and then you just give the remaining members a single tent. So now tent plus is equal to uni by 3, and then for the remaining members you assign 1 tent each. So it will be uni percentage 3, right? So you assign 3 membered tents to uni by 3 people, And then for the remaining people, you assign 1/10 each. So it will be 10 plus is equal to uni percentage 3. And then you just add the introvert count, because obviously you have no other option, but then to give each person 1/10. So the answer will be 10 plus is equal to introvert. You add introvert. So let me just put it down all together because that was too clumsy initially. So, okay. So 10 is equal to extrovert by 3 plus, if extrovert count is if extrovert percentage 3 is 0, I mean you need to if extrovert percentage 3 equal to 0, then okay, let me just take the two add variables. Okay, or let us do a thing. If we handle the -1 case already, what will be the answer if we assuming that we have handled the -1 case already? Drop the answer for that in the chat box. Assuming we have handled the -1 case already, that is, we've checked that universals are greater, I mean, the universal count is greater than the to add value. Okay. A plus B plus C by 3 plus C percentage 3. Actually, shall I just code this up? I think this seems too messy on board. Hmm. I'll code it in IB. Okay. Also, just go through as I'm writing the template, because there is no much difference between C and C++. I strongly insist you guys to switch to C++ or Python, because yeah. Okay. So int, introvert, extrovert, and universal. Okay. Let me take input, introvert, extrovert, and uh, universal. Okay. Let tens be the minimum number of tens that I'll require. I'll initialize it to 0. And first, what do? We assign uh, first we assign extroverts into tens of 3, and then the remaining extroverts will be what are the remaining extroverts? Extroverts will be extrovert percentage 3. These are the remaining extroverts which have to be paired with any of the universals. Okay, int to add. To add is the number of universals you have to you'll need to pair up with the remaining extroverts. Okay, so that should be uh, to add is equal to let us initialize it to 0. If ex equal to 0, what will it be? If ex is equal to 0, 2 add will be 0. You need not add anything further. Else, what will it be? It will be EX minus EX percentage 3, isn't it? That means if you have one member, one extra member, you need two extra universal members. If you have two remaining extroverts, you need to add one extra universal member, right? So 2 add will be equal to EX minus EX percentage 3 if EX is not equal, if it is not equal to 0. So now if my universal count is less than 2 add, I won't be able to pair extroverts with, like, I won't be able to give the remaining extroverts a tent containing 3 members. So my answer will be -1. So I'll return -1 here. And I'll just return. Okay. Now, now that I have enough universals to pair up with the extroverts, I'll just do that. So if I pair the remaining, so I'll have to remove to add number of people from universals in order to pair them with the extroverts, the remaining extroverts. So how many tens will I require for them? I'll require 110 for them, right? So tens plus plus, because I've used these universals to pair with the remaining extroverts, which will require 110. Now, for the remaining universals, it will be un by 3. That is, first I'll try to make them as pairs of 3, and for the remaining, I have no option but to give them individual tens. So it is un percentage 3. And then the last thing, the introverts thing is like not even required. Like, you just add it up because you have no other option but then to give them an individual 10. So this should be your answer. Is everyone clear with this? Like, why exactly I did each one of it? Why is it not giving a -1? Second. Uni can also stay 2 in each 10. In that case, is it okay? Or with 2 others as well? Okay, my bad, my bad. So it is uni. Cool, cool. I missed that thing. So you do uni percentage 2, and then the remaining universals will be uni percentage equal to 3, right? Now you can. It is always optimal to give them tens of 2 if possible, and then the remainder will be uni percentage is equal to 2. If there is yet any remainder, done. Cool. Yeah, you got a point. Uni can also stay at 2 in each in that case. Yeah. Just a second. Acha, my bad. Yeah, yeah. 2 add is equal to 3 minus ext percentage 3. It's not ex minus ex percentage. Yeah. Cool. Oh, wait. Wait a minute. Acha, okay. You need to add to the tens only if 2 add is not equal to 0, right? Yeah, cool. Cool. I will submit this now. Acha, okay, okay. Okay. You guys can come up with simpler solutions as well. I mean, simpler one shot, like formula as well. I just wanted you to go through what exactly we are doing in order to minimize the tens. So I wrote everything like in a step-by-step manner. So yeah, this is it. Is like everyone clear? Like at least why we are doing it? Like did you get the point of considering edge cases? Like you need to consider edge cases before just coding up what comes into your mind. Is everyone okay with this? If everyone is okay with it, we'll move to the next problem. Okay, cool. Okay. Yeah, I shared it in the chat box. The next question, read the question. I'll give you 2 minutes of time to read the question. If anyone has a solution, I mean, you just don't have to tell me the exact procedure and all of that. You just tell me your approach, like how you planning to solve this problem. You can just write that in the chat box. So, did you guys read the question? I'll just explain the question by then. So basically, you're given an array of n integers. You're given an array of n integers, uh, and each integer denotes basically there are n jars. Okay, and in each jar you have some amount of liquid filled in it. Okay, this is like 4 liters of water. This is like 5 liters of water. This is 5 liters of water, and there is no 0 liters of water in this, and there is 6 liters of water in this types. Okay, and you can pour the water from uh, a I minus 1 to ai. That is, you can pour water from a preceding jug to a succeeding jug, and you can perform this operation multiple times. Like each time you can pour any amount of liquid that you wish to from a jar that is to the left to I mean in I minus 1 position to I position. That is just a preceding jar to a succeeding jar. You can transfer any amount of liquid that you want, and you can perform this operation multiple times. You need to perform this operation in such a way that the amount of liquid in all the jars becomes equal. Okay, this is the question. And the operation that you can perform is you can transfer any amount of liquid from ai minus 1 to ai. Okay, okay, my bad. Okay, so sorry, it is not ai minus 1 to ai. You can choose any two indices I comma j, and you need to pour the liquid from the index that is lesser to the index that is greater. They need not be consecutive. That is, you can pour water from, that is, you can pour water from 4 to 0 as well. You can pour water from 4 to 0 as well. It is not mandatory to pour the water from 4 to 5 only. So basically, you choose two indices and it pour liquid from the lower index to the higher index. Okay, any amount of liquid that you wish to. So any approaches to the question? Okay, I already have a few solutions in the chat box. Iterate from left to right and pour excess water in the container, in the next container. Go left to right and check if the amount is total by n or not. If less, then print no. If not, then make it a total by n and add the water to the next container. Great. Anirudh, Rehan, most of you already gave the solution. Yeah, that is the solution to the problem. Anyone else? So basically, in order to make the amount of liquid equal in all the jars, what is the amount that has to be present after all the operations that you perform? Like every jar should contain the same amount of liquid is what he mentioned, right? So after all the operations, each jar must contain how much amount of liquid? Sum of all the sum of amount of liquid in all the jars, sum of ai by the number of jars, right? This is the amount of liquid that has to be present in each jar after performing all the operations. Is everyone clear with this one? So now what you do is nothing but you just iterate from left to right, and then you make sure every jar has this much amount of liquid in it. And if there is any remaining liquid, you just pour it to the next jar because you can use it further. You can use it for the further operations. Now what you do is, let's take the previous example only, 45506, right? So now you have 4, 5, 5, 0, 6. Now what do you do? What is the value of liquid that has to be present in each of the containers? It is 5 plus 5, 10, 10 plus 4, 14 plus 6, 20. 20 by 20 by 1, 2, 3, 4, 5. 3, 4, 5, right? 5. So you need to have 4 liters of water in each of the containers, right? Now what do? You just iterate from left to right, because you can only pour liquid from a container that is on the left to a container that is on the right. Not necessarily to be consecutive, but then you can only pour liquid from a container that is on the left to a container that is on the right. Okay, so now initially you start off with 4. Now you already have 4 liters of liquid in it, so you don't do anything. You move to the next thing. Now you have 5 liters of liquid. You need only 4 liters of liquid to be in this jar, so you transfer 1 liter of liquid to the next container. So now here, now this will become 6. Now you have 6 liters of liquid in your third container, but you need only 4 liters to be present here. So what do? You keep 4 liters in this and you transfer the remaining 2 liters to the next container. Now the amount of liquid present in this is 2 liters. Can I by any way make this 4? You have 4, 4, 4, 2, 6. Is there any way that I can make this 4? No, right? Because there is no amount of liquid remaining in the left half of it for me to add it to this jar. This is the, like, I transferred the maximum amount of liquid that I can transfer to this jar, and still yet it does not have 4 as its at least 4 liters of liquid. So it is no. I want to be able to make the amount of liquids in the jars equal by performing the operation multiple times on this kind of array. Is this clear? Now let us consider another example. Say you have 6, 5, 5, 1, 3, 4, 4. Now what is the sum of all the elements in the array? 6 plus 5 plus 5, 5, 5, 10, 16. 16 plus 4, 20, 20 plus 4, 24, 24 plus 4, 28, 28, and there are 7 elements in the array. So you need to have 4 liters of water in each of the jar, right? So now what do? There is 2 liters excess in this jar, so you transfer that 2 liters to this jar. Now you have 7 liters in this jar, but you require only 4, so you transfer 3 liters to this jar. Now you have 8 liters in this jar, but you need only 4, so you transfer 4 liters to this jar. Now this becomes 5, but you require only 4 liters, so you transfer 4 liter. How many liters? You transfer 1 liter to this jar. This becomes 4. Now you have already have 4, so you don't transfer anything. This is 4. This is 4 already, so it is a yes. Is everyone clear with how the solution is working? Clear? Okay, cool. Should I code this up, or will you do it by yourself? If you want me to code it up, I'll code it up. Just put a thumbs up if you want me to code it up. We will do it by ourselves. Okay, cool. So yeah, done. So I'm leaving it to you people, guys. You just try it. So this is the approach. Like when it comes to competitive programming, the part, like there are 2 parts. The first thing is you thinking, like you approaching to this, like approaching the solution, like you thinking about how the question is to be solved. You coming, like logically thinking about how the question is to be solved, and then comes the implementation part. So we are going to focus mainly on the logical thinking part. It is like CP is completely like 80% of how you approach the solution, how you logically come to a solution to the problem, and 20% or 10% of implementation. It varies from problem to problem, but now let us just focus on how we are approaching, like how are we able to logically uh, get to the solution or not. Okay, so now, so does anyone know what like what kind of problems we solved so far? Like we solved 3 problems, right? Do you know what kind of problems they are called? I guess some of you must already be knowing. Cool. I expected this though. Okay, so yeah, the problems that we solved now come under greedy algorithms. So what are greedy algorithms in the sense? Okay, so basically, in greedy algorithms, you don't check all possible solutions. You just feel ki this is the direction that I have to go. If I go in this direction, I will definitely end up in my solution. Like possibly, like I will end up in a solution. That is known as a greedy approach to a problem. So basically, in a greedy approach, you don't check for all possible solutions. Rather, you go by your not exactly an intuition, but you go by you go in the direction in which you know that you expect a solution in that direction. Okay, so for example, say that maximize the beauty wala question. You did not rearrange the array multiple times and then take the differences of all the elements and then figure out that the best case is when it is sorted, right? You for a fact know that when an array is sorted, that gives the optimal answer, so you directly you directly think of the solution in that direction. You just don't explore all the possible solutions and then consider the maximum out of all the possible solutions. You go in a direction in which you get the solution. So that is known as a greedy approach. Okay, so let me tell you, there are like stages while solving a greedy problem. Like the first stage is like when you look at the problem, like the 3 problems that we solved so far are like on an easy medium level. But then in general, greedy problems, when you look at a problem, you feel like um okay, I mean, I'm gonna give up, bro. I'm like, I have no clue of how this can be solved. This is the first stage when you look at a greedy problem, and then comes the intuition stage, and then you look at the problem and you feel like this probably can be done this way, but you don't exactly know why that works. You feel that if I approach the solution in this way, I might get the optimal solution. So this is the second stage in while you're trying to solve a greedy algorithm. The third stage and the most important stage is the proving stage. Okay, you have an intuition in your mind that if I approach the problem in this direction, I might get a solution. Like I have like 90% surety that I will get a solution. But then what is important is you proving why that is correct. Like, why will I get a solution if I go in that particular direction? Do I actually get a solution? Do I get the optimal solution if I move in that direction or not? So proving is very important. First thing is like giving up state. Second thing is like intuition, and third thing is proving your intuition. And after you prove your intuition, you code it up. You code what your whatever the solution you think of. Okay. And most of the times there are problems which seem as if you can solve it greedily, but then you won't be able to like there won't exist any greedy solution for it. So you rather not jump into your intuitions, just try to prove why exactly it is working. You can take the maximize beauty like maximize the beauty of the array as the example. If you would ask me, see, like the first thing that comes into your mind when you see the question is like, yeah, you can probably sort the array and you can just take the differences, but exactly when you try to prove it, you understand, okay, that is the optimal solution. You don't have a better solution than that, right? So it is very important to prove your intuition in greedy algorithms. Come on, chalo. I think we'll move to the next topic, I guess. Is everyone okay with greedy problems? I mean, uh, greedy problems are more like as many problems as you solve, the more experience you get, and the more the more easily you will be able to get intuitions, and the more easily you'll be able to prove your intuitions. So it is all about experience, practice, and all of that. People, I understand it's already late. Can you please just spare half an hour more of time? I'm gonna like explain bit manipulation now. It is like quite a lot important. Yeah, sure. Done. Okay. So now comes bit manipulation. So I guess you all have a gist of what bit manipulation is, right? Like, okay, let's just start off with. Oh God. Hmm. Okay. So in bit manipulation, the first thing is you have bitwise operators. Uh, so there are like you have and, you have or, you have XOR, you have bitwise not operator, you have left shift, and you have right shift. You guys must have already heard about and, or, XOR operators already. Not is like it is basically like a complement in a bit representation. If you have something like this, 0 will be replaced with 1, and 1 will be replaced with 0, right? So this is nothing but bitwise not. And let us discuss about that and, or, and XOR as well. Left shift is uh, this symbol is known as left shift symbol, and this symbol is known as right shift symbol. So let's just briefly see like what and, or, XOR does. I guess you all must be already knowing this, but just as in, if A and B are 0, can you just write the answers for these in chat? A and B is 0. A or B will be 0. If A and B are 0, A or B will be 0, 0, 0, 0. If A is like one of it is 0 and one of it is 1, A and B will be 0. Only when both of them are ones, A and B will be 1. In all the other cases, A and B will be 0. Okay. And A or B is 0 only when both of them are 0. At least if one of it is 1, it will be 1. Okay. A XOR B will be equal to 1 if both the values are different. Like if it is 0, 1 or 1, 0, it will be 1. In the cases where both of them are equal, it will become 0. Like 0, 0, it is 0. And for 1, 1 also, it is 0. Okay. So this is like the basic how a basic thing like how and or and XOR work. Now I already told you about the not operator, not just swaps toggles 1 to 0 and 0 to 1. Coming to left shift and right shift operators. So just a second. I used to get confused a lot with the left shift and right shift operators. So basically, left shift is towards the right and right shift is towards the left. Okay. So this is the, wait, let me see. This is the right shift operator. So what does the right shift operator do is, see, say this is the bit representation of some number. This is 2 power 0, 2 power 1, 2 power 2, 2 power 3, so on. Okay. So now what the right shift operator does is it moves every bit one position to the right. Not exactly one position, you can specify. Say I specified n right shift 1. It shifts the bits of n, the bits in n, one position to the right. If I do n right shift 2, it shifts the bits of n two positions to the right. Okay. Now this 0 is truncated. It is truncated and this becomes 1 0 1 0 1. This is n right shift 1. When you do n right shift 2, you'll the bits of n will undergo two shifts, two right shifts. So now it moves one more position to the right. It will become, this 1 is truncated now. It becomes 0 1 0 1 0, so on here. Done. Is everyone clear with right shift? So apparently what happens when you right shift is the number apparently gets divided by 2. Say you have, let's take a simpler number. Say you have 5. N is equal to 5. What is 5 right shift 1? You just right shift this by 1, right? And there are zeros before. Just, I mean, so it becomes 1 0, which is 5 right shift 1 is 2, right? So apparently you're just dividing the number, floor dividing the number by 2 each time you are right shifting it by 1. It is analogous to n right shift 1 is analogous to n divided by 2, and n right shift k is analogous to n divided by 2 power k. Is everyone okay with this? And it would be great if you could write your make your notes, like at least of the important identities or things like that, so that it'll be easier for you after on. Okay. So this is what it is. And then coming to the left shift operator. Left shift is towards the right, like right shift is towards the left. Okay. So now in left shift, what happens is, there you shifted the numbers to the right, here you shift the numbers to the left, one step to the left. And here, say, and here you might assume ki this number will get truncated, but this number is not going to get truncated because there are zeros further. Like you don't write them every time, but then there are zeros before this, so this just gets shifted to the left. Okay. All the numbers get shifted one position to the left in left shift. Say you have 1 0 1 0 1, this will become 1 0 1 0 1 0, and a new 0 gets added to the at the rightmost position. So what is apparently happening here when you do n left shift? Oh, I'm sorry. Okay. Okay, when you do n left shift 1, what is happening here? When you do n left shift 1, anyone in the chat? Yeah, cool. So same like when you're right shifting the number by 1, it gets divided by 2. When you're left shifting a number by 1, it gets multiplied by 2. Okay, so n left shift 1 is analogous to n multiplied by 2. Okay. Now, similarly, n left shift k is analogous to n multiplied by 2 power k. Make sense? Okay. And let me tell you guys, arithmetic operators are comparatively slower than bitwise operators. So whenever you have to use something like n into 2 or n into 2 power something in your code, you can use this instead of this, because bitwise operators are comparatively faster than arithmetic operators. Okay, cool. Now let's move on to the next thing. I'll just let's just learn, like, just a brain exercise. I'll just give you some tasks or whatever. You just answer what the answer could be for these. Okay, these are like identities you can assume. So a is some number. It is not 1 or 0, it is some number. So what is the value of a or 1, a or 0, a or a? You give the answer to me in terms of a only. Okay. Can you just give me the answer to these? First, let us start with or. Give me the answer for a or 1, a or 0, and a or a in the chat box. A or 1 will be, is it 1? I told you already, do not consider a to be 1 or 0. A is not 1 or 0. A can be some number, say this is a. Now this or 1 is, what is this or 1? Give the answer to me in terms of a. Cool, some people are telling a. Is it a? Is it a always? So basically, in bitwise operation, everything depends on how you are able to visualize the number in the form of bits. That is like, if you are just able to if you just know how and or XOR works, and if you are able to visualize the number in terms of bits, the there is nothing to do with bit manipulation. Like it's over types. Okay, any other answers for a or 1? Most of them are replying with 1 and a. The people who are replying with 1, I assume you are considering a to be only 1 or 0, but it is not 1 or 0, it can be any number. Okay, some people, Rasagna Kudikyala is answering with a plus 1 if a is even. If a is 1, if a is even, a, else a plus 1. Rutvik. Rasagna and Rutvik are on the opposite sides. If a is even, a plus 1, else a. Is uh, is everyone agreeing with this key? A, if a is even, the answer for a or 1 is a plus 1, else it is a. Okay, let's just see. Let us consider this is my a. Okay, some random number. Let me just not compute it as well. And 1 is obviously something like this. The bit representation of 1 is something like this. So in or representation, these are all zeros. So irrespective of what is here, the numbers that are, I mean, like the bits that are present in a before this bit will be like just coming down to the answer. So this will remain same as whatever is there in a. And coming to this part, if the bit in the 2 power 0th bit in a is set, if the 2 power 0th bit in a is unset, uh, you will still get a 1 here, because there is a 1 in the 2 power 0th position of 1, right? So here the a is even or odd. If 2 power 0th bit of a number is unset, is the number even or odd? Even. Cool. You have this clarity, right? So when 2 power 0th bit of a number is unset, that means it is an even number. It is an even number, and for an even number, when you OR it with 1, the 2 power 0th bit in 1 is set, so you get a 1 here. Now this was our a, right? And you have added 2 power 0 to it. That means you have added a 1 to it. So when a number is even, that is when the 0th bit is 2 power 0th bit is unset in a, the answer will be a plus 1. If the bit is set in a, what will be the answer? It is already set in a, and it is it doesn't make a difference, right? I mean, you get a as the answer, because it is set in a and it is set in 1 as well. You are not adding anything extra to it. So the answer for a or 1 is a plus 1 if a is even, and it is a when a is odd. Is everyone clear with this? Okay, cool. Now coming to A or 0, drop your answers for A or 0. A, cool. I think this is like very basic because whatever you like, whatever the number is, when there are all zeros, irrespective of like if there is a 1 here, you get a 1 here. If there is a 0 here, you get a 0 here. So you get nothing but you get A as the answer when you are A with 0. So this is quite basic. You get A as the answer. Now A or A will be, yeah, A or A will be A as well because, yeah, basic one again. Like in every bit position, it will either be set in both or unset in both. So the same thing comes down to the answer. Next, coming to A and 1. What is the answer for A and 1? You can just take some examples and try out. I don't know. I'm kind of in love with this 10101, I guess. If A is even, 0 else 1. 1 if even, 0 if odd. Rishidhar and Rutvik are on the opposite sides. You guys are telling opposite answer. 6 and 1. If A is odd. Mm-hmm. Okay. Okay, so I have got some answers. So if even, 0 else 1. Okay, Kaushik is telling ki if it is even, it is 0, else it is 1. 0 if even, 1 if odd. Okay, cool. Nice. So let us take this example. Irrespective of what bits are present before, like after the 2 power 0th bit, irrespective of what they are, they'll always be 0 because 0 and anything will be equal to 0. And all the bits in one, uh, except for 2 power 0th bit, are unset. So you'll have zeros here. And if the bit is set in, if the 2 power 0th bit is set in A, it will be set in the result, or else it won't be set in the result. Right? If the 2 power 0th bit is set in the result, 1 and 1 will give you a 1. Else, if this is a 0, you'll get a 0 in the answer. That means if 2 power 0th bit is set in the sense, if it is odd, you get 1. If it is even, you get a 0. Cool. Most of you gave the right answer. Sushmita, Kaushik, Shravani, most of you gave the right answer. If it is even, it is 0 if even, 1 if odd. Next, A and 0. What is the answer for A and 0? Cool. This is basic as well. Irrespective of what bits are present in A, uh, like all the bits are 0 and 0, so you get a 0 as the answer. A and A. Cool. Yeah. Uh, like you get A as the answer because the bits in both A and A are similar. So one, you either get a one and one wala case, or 0 and 0 wala case. In either of the things, for 1 and 1 you get 1, 0 and 0 gets 0. So it is like A and A equals A. And for A XOR 1, for A XOR 1, okay, Ritvik is like it is A if even, and A is, if A is even, it is A plus 1, else A, it seems. Anyone with any different answer? I don't think so. Is there any other answer? Anyone else? Chalo, ya fir tell me the answer for A XOR A. What is the answer for A XOR A? Apurva says 1. How is it 1? Jahnavi, Abhishek, Karthik, Anirudh. Kaushik is like if even 0 else 1. How Kaushik? So basically A XOR A, matlab you will have the same bits in both the thing, right? If it is a 1 here, you have a 1 here. If it is a 0 here you have a 0 here. And whenever the bits are same in both A and B, A XOR, like, I mean, whenever the bits are same, the result is 0, right? In XOR. So obviously the answer will be 0 because the bits are same at each bit position. So you get a 0 as the answer. So A XOR A is 0. Now coming to A XOR 0, what is A XOR 0? Rutvik, is your answer for A XOR 0 or A XOR 1? A XOR 0? You told the same thing for A XOR 1 as well, right? Achha, you're telling the opposite thing for A XOR 0. Even A, odd, A plus 1. Guys, I want the answer for A XOR 0. A XOR 0 is A. Nihesh. Cool. Uh-huh. A. Most of them, like some of them are telling that the answer is A, and some of them are like even A, odd A plus 1. Like how is it even A and odd A plus 1? A XOR A and A XOR 1 are opposites. Like how exactly? A XOR 1 is equal to even is equal to A minus 1. Nihesh. Mm-hmm. For even A plus 1 in A XOR 1. Okay, let me give you an example. For the same example, 10101 XOR 00000. What is your answer, people? Okay, tell me the answer for A XOR 0. Don't get confused. I'm asking you the answer for A XOR 0. Sushmita, okay, Sushmita and Taruni are telling it is A. There are people who are still telling that the answer is A plus 1 when even in A is odd or something. Pavitra A, cool. Santosh A. A XOR A is 0 is equal to A. Cool. A XOR 0 is A, people, because uh, you only have zeros in 0, right? Okay. So whenever if there is okay, so if there is a like if there is a 1 here, it becomes 1 here because 1s are 0 is 0. And if there is a 0 here, it becomes 0 again because zeros are 0 is 0. If both the bits are same, it becomes 0. If they're different, it becomes 1. So it comes back to A. A XOR 0 is A only. Is everyone clear with this? Whenever there is a 0, you only have zeros in the bit representation of 0, right? So whenever you have a 1, it the answer will also have 1 in the ith bit because 1 XOR 0 is 1 and 0 XOR 0 is 0. So you get back the same number. Cool. Now tell me the answer for A XOR 1. Think of all the possible cases, people. Pavitra says A plus 1 if it is odd. Sorry, A plus 1 if it is even and A minus 1 if it is odd. Okay, acha. Rasagna says A plus 1 if it is even. Rutvik says A if it is even and A plus 1. A is even. If A is even, A plus 1 else A. Okay. Rutvik, tell me the answer for 10101 only. 10101. Zor, what is the answer for this, Rutvik? Nihesh, you're telling the same, almost like something similar. Like, what is the answer for this one? In this case, A is odd, right? What is the answer? 10? Yeah, 10100. So is that equal to A? Here A is an odd number because 2 power 0 is set, right? Okay. Okay, odd A plus 1, even A minus 1 by Nihesh. Nihesh, you tell ki if it is even, it is A minus 1. If it is odd, it is A plus 1. Is this an even number or an odd number? 2 per, when, if the 2 power 0th bit is set, is it an odd number or an even number? This example is of an odd number, right? So for an odd number, what is the answer? Karthik says odd number A minus 1. Cool. Nihesh, is it A plus 1? Okay. Odd A minus 1, even A plus 1. Mari Rushindra. Anirudh, odd A minus 1, even A plus 1. Sushmita, odd A plus 1, even A. Sushmita, is it A for even? Consider this case. What is the answer for this one? Odd then A minus 1, even then A plus 1. Okay, cool, Ritvik. Sushmita, what is the answer for this one? The example that I just mentioned. Okay, so the same thing here, the bits do not change, they just come down to the answer because 0 XOR anything will return the same number. So 1 0 1 0, all these bits are the same bits as in A. Like whatever are present in A up to here will be coming down to the answer. What changes is the change depends on the whether the bit is set in the 2 power 0th position or not. If the bit is not set in the 2 power 0th position, that means if the number is even, 0 XOR 1 will result in 1, right? So your answer will be A plus 1 if the number is even. That is, if the 2 power 0th bit is unset, your answer will be A plus 1 for A XOR 1. And if the number is set, if the 2 power 0th bit is set in A, 1 and 1 gets cancelled. Like, I mean, like 1 XOR 1 equals 0. Since there is a 1 in the bit representation, 2 power 0th bit of 1, it becomes 0, and all these bits as usual come down to the answer because 0 XOR anything will give the same number. So this will be A minus 1. Oh wait, just a second. Yeah, A minus 1 when it is odd. Cool. Is everyone okay with it? Please note down these identities, people. I mean, they might be useful to you in, like, just in case if you want to refer in the future. So it is A plus 1 if it is A plus 1 if it is even, and A minus 1 if it is odd. Okay, cool, done. Now let me give you a question. I'll give you an array consisting of integers, positive integers, and in that array every number will be repeated twice except for one number. What is how will you find out the number that is not repeating twice? I mean, the number that is repeating only once. Okay, XOR. Why exactly XOR? Can you please write down the statement of proof, just a single line statement of proof in the chat box? Cool. A XOR A is equal to 0. Yeah, you guys are pretty good, Ray. Okay, so when you XOR two same numbers, A XOR A is equal to 0. You already learned this in the identities. So this will be 0. 2 XOR 2 will be 0. 3 XOR 3 will be 0. And you will be left over with 5. 0 XOR anything will be 0 only. And then 0 XOR anything is not 0. 0 XOR anything is itself, but then 0 XOR 0 XOR 0, all that will come down to 0 again. And 0 XOR 5 will give you 5. So you just XOR the whole thing. Duplicates, like the repeating elements, if they're in even number, the XOR of all of them will be equal to 0. So you'll be left out with the number that is not repeating twice. That is the number that occurs only once. Cool. Everyone, Abhinav, Ved, Abhishek, Apurva, all of you gave the right answer, people. And this works in O of n. And yeah, just to mention, and or, like all of these and or XOR, they follow both commutativity. They're both commutative and associative. That means A and B is equal to B and A. Similarly, A or B is equal to B or A or A XOR C is equal to C XOR A. Associativity in the sense, A, say you have A, B, C, you can evaluate B and C first and then evaluate A and the result of this, or you can evaluate A and B first and then evaluate the result with, you can then AND the result of A and B with C. Cool? Is everyone clear with this? Done. And let me just tell another thing, uh, a small thing to note. If A XOR B is equal to C, you can write, it implies that A XOR C will be equal to B. Okay, this is a property of XOR. If A XOR B will equal to some number C, then C XOR A will be equal to B. ठीक है? We can use for swapping. Yeah, you can use XOR for swapping as well. Uh, yeah, that is actually a good question. Can you just write down the code for swapping two numbers without using, without using any temporary variable using XOR? Apurva, can you just write down? Okay, we can use using A is equal to XOR B. Cool. So what happens here is, okay, people, everyone just try swapping two numbers without using a temporary variable using XOR. Cool. So what happens here is, this is the code that you guys are writing. A is equal to XOR B, B is equal to XOR B, A is equal to XOR B. So what actually happens here? Initially, in this step, A will be equal to A XOR B. So now in the second step, B will be equal to this. These are the initial values: A XOR B XOR B. That means B. Oh God, that is B. B XOR B will be equal to 0. You shouldn't be canceling like this. Just so B will be equal to A now, and then A. If you A will be, if you do A is equal to A XOR B, you'll get A is equal to, in A, what is stored in A XOR B, right? So it will be A XOR B XOR B, which is nothing but, wait, just a minute, and A XOR B XOR A is stored in B now, so you get A is equal to B. So you can use this thing. You can use XOR to swap to values of variables as well. Uh, just a second. People, so what do you say? Shall we just stop the session for now? Or shall we continue tomorrow? Okay, cool. I guess you learned something new today. Also, I insist you on switching from C to C++ or Python or like any high level language, but not C, because you have many data structures like stack queue and all of those. Like, obviously, you have it in your data structures, right? When it comes to C, you implement everything from scratch. But whereas in uh, C++ or Java or Python, you have inbuilt libraries for all of them. So basically, what you need to focus on is you need to uh, train your brain to think for come up for solutions to new problems. Like there is no use of implementing something that is already there. Like say you have if you plan to build a website that is already there, like if you plan to build something that is similar to Swiggy or Zomato, no one is gonna it is like waste of time, because what is the use of building something that is already existing? You need to train your brain to come up with solutions to problems that are new. You need to train your brain in that way. You need to train your brain to think rather than focusing on implementation part. So I'd strongly recommend you to switch to either C++ or Python or Java. Can you suggest a channel or website for learning C++? um, I'd suggest Code with Harry. That is like a very good channel. And also, for people who are planning to switch to C++ or Java or Python, just ignore the part of class-based implementation encapsulation. Just skip the oops part, because that is not so important when it comes to competitive programming. Just learn the STL part, and if you have to switch from C to C++, it is like very basic. You just change the header, you change stdio.h to bit/std, and you just change the scanf statement to scanf statements to C in, and printf statements to C out. For Python, I generally don't code much in Python, but I'll just I'll just drop the links if I find any in our Insta story, so you can just refer to them. I'll just uh, go through and I'll just let you know. Apart from STLs, what else should we learn in C++? Coming to CP, it is enough if you just go through STLs, just the basic syntax. Like, you have stacks, queues, you have vectors, etc., etc. in STLs. You have the sort function and all of those. If you are good to go with those, it'll be enough for CP. For now, I'd recommend you to skip the oops part, the class-based implementation, encapsulation. Just don't get overwhelmed with those terms. You'll, however, be learning it in your syllabus. Just learn the STLs part and just learn the syntaxes that are enough for you to implement the code. Also, don't think I'll learn the whole documentation, I'll learn the syntaxes, and then I'll start coding in C++. That is like, instead of that, I'd suggest just switch to C++ first, and as you solve problems, there'll be a problem where you'll have to use a sort function and you don't know the syntax for it. You Google it, you learn it, you use it. And that is how you actually learn a language. That is like the best way that you can learn a language. Not just C++, for any language, it is the same thing. Just start solving problems in it, and wherever you find that you are not aware of a syntax, just Google it, and then you're good to go with it. Any other questions, people?
Yeah, so we've basically reached the end of the session for today, right? So, and I hope that you've learned something new at least today from our side, right? So tomorrow we're going to jump into a little more deeper topics like frequency arrays, pre-computation and stuff, right? So please revise whatever. Please revise whatever we've taught you so far. Like, I hope you've made some notes. um yeah, so if you haven't, just ask people who have, right? So these basics of time complexity and stuff, the basics of bit manipulation, like they're like the building blocks of CP. Like, unless you do that, you are going to struggle in CP a lot if you don't know, if you do not know those concepts. And learning those concepts like this early up in your career, it will basically help you a lot, right? So yeah, that's been us. Let's all meet tomorrow with the same enthusiasm as today. See you guys. Bye bye.